Thank you for joining this lesson. We're going to discuss the angle properties of a circle. Number 20. In the figure below, O is the center of the circle. MT is a tangent to the circle at point P. Angle PQS is equal to 56 degrees. PQRS are points on the circumference of the circle. SQT is a straight line. So SQT is a straight line. MT is a tangent at P. Then P, Q, R, and S are points on the circle. Then we have O as the center. Find part 1, angle PRQ. So angle PRQ, we're going to subtend that angle PRQ. This is the angle we need, angle PRQ. And we're going to find its value slowly. So as we can see, because this is 56 and SQ is a diameter, then the angle subtended at the circumference by the diameter of a circle is usually equal to 90 degrees. So the angle at P, this angle is equal to exactly 90 degrees according to the properties of angles in a circle. So with 90 and 56, then the remaining angle is going to be 34 at this point. 34 degrees. Therefore, the value of angle PRQ is going to be 34 degrees, just because the chord PQ, which subtends 34 degrees at this point, is also subtending the angle at R. So we have 34 degrees again at this point, because if this is a chord and it subtends an angle at this point, and the same chord is subtending an angle at S, then the two angles subtended by the same chord are supposed to be equal. So in brackets, we can give the reason. This is because they are angles subtended by the same chord. By the same chord. The angles subtended by the same chord at the circumference of a circle are supposed to be equal. The next is angle QPT. QPT. The value of this angle is again going to be 34 degrees. So what you're going to say is that QPT is going to be 34 degrees. Reason being, when we have a tangent and a chord intersecting to make an angle, and the same chord subtends an angle at the circumference, either to this point or even this one, we usually say that the angle at the circumference is equal to the angle subtended by the chord and the tangent. Or rather, the angle subtended by a chord and a tangent is equal to the angle subtended by the same chord in the alternate segment. So we will say this is angle subtended in the alternate segment. In the alternate segment, it just has to be equal with the angle made by the chord and the tangent. We also have another angle, PTQ. Angle PTQ. Just this angle. And we're going to use angles in a triangle. Because we got 56 and this is a straight line, then it means the angles on a straight line should be 180. So we're going to have 124 degrees at this point. Then now we have PQT as a triangle, and we have the two angles given. This means automatically we will subtract from 180, 124, and 34. And this will give us exactly 22 degrees. So PTQ equals to 22 degrees angles in a triangle. This can be a reasonable reason why we have followed that route. Given that QT, this is a line now, a length, QT equals to 5. So QT equals to 5 centimeters. PT 9.4 centimeters. So PT is this tangent, 9.4 centimeters. Calculate to 1 decimal place the area of the circle, then use pi as 3.142 for 4 marks. So what you're going to do here is to first get, we cannot get area of a circle until we get the radius, which maybe might be calculated through first of all getting the diameter. So this diameter is unknown and we can let it to be diameter D. So when we take the total length from S to T, according to the relations between chords and tangents, ST multiplied by QT, the total length times the outer portion, which is QT, should give us the same as PT squared. So we will take this length, which is unknown, as D, so that we may say D plus 5 to be the total length. We take D plus 5. Then we multiply with the outer portion, which is 5. We're supposed to get the tangent squared, which is 9.4 squared. So we're going to have 5D plus 25 equals to 9.4 squared. This gives us 88.36. So when we remain with 5D at this point, we will subtract 25 from the other side and have 63.36. So that will remain with D. Now we need to divide through by 5. This gives us 12.672 centimeters. If this is the diameter, now we can get the radius by dividing diameter by 2. So divide by 2, this gives us 6.336 centimeters. Now the big question was to find or to calculate to 1 decimal place the area of the circle. Area of a circle is usually given by pi r squared. So I'm going to substitute this formula and have a pi of 3.142 as instructed times 3.142 times the radius, which is 6.336 squared. So this is going to give us the area for the given circle. So we have 3.142 times the answer squared. This is giving us 126.135. Then according to the instructions, to 1 decimal place, 12.1 square centimeters.